Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers averages and dispersion. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. The times that 80 customers waited at a supermarket checkout, and that information has been put into a grouped frequency table. Now question 6a asks, in which class interval is the median? Now the easiest way to work out a median is using cumulative frequency. So I'm going to add an extra column to my table, which I'm going to put CF at the top for cumulative frequency. Now you get cumulative frequency by adding the new frequency to the existing frequency up to that point. So the first value is going to be 32 and then the next value is going to be 32 plus 19, which gives you 42, 51. The next one is going to be 51 plus 20, which is 71, and then 78 and then 80. Now whenever you're doing cumulative frequency, it's a good idea just to double check your answer here is the same as the one they give you in a question, just as a little check on your own adding up. Mine does, mine works. Now to work out where the median is the person in the middle. So if you've got 80 people, then you can find where the middle person is by adding 1 and divided by 2. So the middle person is the 40.5th person. Now, where do they lie in the data? Well, we can just use our cumulative frequency to work that out. We can see that the 32 people were in the first category, and then person 33 to 51 are going to be in the next category up, and that's going to include our 40 and 41st person. So this group here then is going to be the solution. So let's ring that. Okay, so part B asks, the manager of a supermarket says 90% of our customers wait less than 6 minutes. Does the data support this statement? Okay, so going back to the data, how many people did wait less than 6 minutes? Well, the people who waited less than 6 minutes are going to be all the people in the 0 to 2, 2 to 4 and 4 to 6 category. Now we've already added that up. Our cumulative frequency says there are 71 people who are in those first 3 groups. So we just need to now work out whether or not 71 is 90% of 80. So what is 71 out of 80 as a percentage? Okay, typing that into the calculator, 71 divided by 80 equals, now you see it gives you as a fraction, but if you press the symbolic to decimal button, that converts it to 0.8875 for us, 0.8875, which is 88.75%. Now the question didn't actually ask us to work out the percentage, although we do need to show our method. It asked, does the data support the statement? So having looked at our result, can we say that the manager was correct in his statement? Now actually the mark scheme, it gives you credit if you say yes or no here, depending on what you say. So you could say yes, 88.75 rounds to 90, so it was reasonable for the manager to say that. Or you could say no, 88.75% is below 90%. Personally, I think the manager's stretching it a little bit here by saying 90%, so I'm going to go with no. I'm going to say no, 88.75% is below 90%. The table shows information about the times for 100 people to complete the task. So we can see that this group frequency table goes from 0 up to 20, but we're told the actual shortest time was 3 minutes 40 seconds, and we want to work out what the greatest possible range of times is. So we know for sure that the lowest value is 3 minutes 40, but the largest value, so that we'll need in order to find the range, we're only given as a grouped value, so somewhere between 15 and 20. So we're going to have to assume then that our maximum value is going to be at the upper end of this group. So the greatest possible range is going to be our largest value, which is 20, minus the smallest value, which we're told is 3 minutes and 40 seconds. So 20 take away 3 minutes 40 seconds is going to be 16 minutes and 20 seconds. So 16 minutes 20. Now part B says, Jack says the median time is exactly 10 minutes. Give a reason why he must be incorrect. The median time is exactly 10 minutes. Well, the median value is the time taken by the middle person, and if I've got 100 people, then the middle person is going to be 101 over 2, isn't it? It's the 50.5th person. So where do they lie in the data set? Cumulative frequency tells me that my first 17 are in there. 17 plus 28 is 38, 40, 45, so that category goes up to 45. And then the next group goes from 46 up to 78. So my 50.5th value is going to be in that range, in the 10 to 15 category. So you can see that t has to be greater than 10 and less than or equal to 15. So it cannot be exactly 10. It's got to be slightly more than 10. If it was exactly 10, it would be in the group below. So we can say that the median lies in the 10 to 15 category, so must be greater than 10. Question 11. The table shows the savings for 30 students in 1 week. So we see that these students are saving between 0 to £5, 5 to £10, 10 to £15, and more than £15. First question is, how many students save more than £5? More than £5 is all the students down here, isn't it? 5 to 10, 10 to 15, and more than 15. So this group of students all saved more than £5. So how many is that altogether? That's going to be 14 plus 9 plus 5. 14 plus 9 is 23, plus 5 is 28. So 28 students saved more than £5. How many students did not save anything? Circle your answer. Okay, so we've got 2 students here who saved between 0 and £5, but can you see that this symbol here is greater than, not greater than or equal to, which means that these 2 students must have saved more than 0, and that might just be 1p, but it's not 0. So we can tell that none of the students did not save anything at all. So they all saved something. Question 6. Gemma has 4 groups of friends on a social media site. The table below shows the number of friends in each group. So in her family group, she's got 8 friends. In her netball group, she's got 8 friends. In her school group, she's got 26. And in her guides group, she has 11. Now, it asks, which group is the mode? Now, mode means the most or most frequently occurring. So we can see that this one was the biggest number, so this one is the mode. So the mode is not the biggest number, it's the group that has the biggest number. So the mode is school, not 26. Okay. Question 9. Here is a frequency table for the times taken to solve a puzzle, and we're asked to circle the class interval that contains the median. The easiest way to find median is to work out which is the median value. So if I've got 100 values, I can find where the median is by taking 100, adding 1 and dividing by 2. So the 50.5 value is the median. Now where does that lie? If we work out cumulative frequency, so that'd be 38. The next cumulative frequency would be these two added together. So 38 and 16 is 48, 50, 54, then 71, 86 and 100. We can see really clearly that the 50th and 51st element are both going to be in this group here, because it starts at 39 and goes on to 54. So this one here is where the median lies. So it's in the 1 to 2 group. Question 7. Here is some information about the times taken by 40 people to fill in a form. So I've got 4 different groups there, and I can see that 3, then 9, then 11, then 17 people took that amount of time. Now if I want to know which class interval the median lies, now I know I've got 40 people, so to find the group for the median I need to take my number of people, add 1 and then divide by 2, and that will tell me where the group is, or which person is in the group. So 40 plus 1 divided by 2 is the 20.5th person, so halfway between the 20th and the 21st person. Probably the easiest way of doing this is looking at cumulative frequency. So the first 3 people in that category, then up to 10 would be 3 plus 9 would be 12 people, and then after that it would be the 13th up to the 23rd person there, just adding those 3 numbers together, the last cumulative frequency being 40. Now looking at the cumulative frequency, it's pretty clear to see that the 20th and the 21st person must be in that group there. It's the 10 to 15 category. Just running through that again, person number 1, 2 and 3 are in category in the first category, then 4 through 12 are in the second category, and then 13 through 23 are in the third category. So the 20th and the 21st person are both in the 10 to 15 group. That one. A charity collection is made. Information about the amounts given by men is shown in the table. The mean amount given by women was £6.30 per person. Compare the mean amounts given by men and women. Okay, we have a grouped frequency table here, so we can't find an exact mean. What we can do though is estimate it using the midpoints of each of the ranges we've been given and use that as an estimate. So 0 to 5. To find the midpoint of those two, you can add them together and divide by 2. So 0 plus 5 is 5, divided by 2 is 2.5. 5 plus 10 is 15, divided by 2 is 7.5, and 10 plus 15 is 25, divided by 2 is 12.5. Okay, so they're my midpoints. So then we need to multiply those by the frequency and then add them up. So 2.5 times 11 is 27.5. 7.5 times 7, 52.5. And 12.5 times 2 is 25. So adding all those up, So 27.5 plus, oops, 27.5 plus 52.5 plus 25 gives me a total of 105. So then the men's mean is going to be my total, which is 105, divided by the number of people, which is 20. So 105 divided by 20 is £5.25. So it looks like the chaps were the cheapskates and gave £5.25 on average. Now, we have found the mean, but we haven't compared the mean yet. So to compare it, we need to say which one is bigger. So women gave more money on average. So that's our comparison. And the table summarizes the amount spent by customers in the shop in 1 hour. And you can see we've got a grouped frequency table. Work out an estimate of the mean amount spent per customer in 1 hour. Okay, so because we've got group data, we need to find our mid values to estimate for each of the ranges. So halfway between 0 and 10, you need to add the two endpoints together and divide by 2 to find the midpoint. So 0 plus 10 is 10, divided by 2 is 5. 10 plus 2 is 30, divided by 2 is 15. 20 plus 30 is 50, divided by 2 is 25. And more than 30 would be a problem, but we've got 0 people there. Okay, and then then we need to find our frequency times A now, don't we? So 5 times 18 is 90. 15 times 15, 225. 7 times 25 is 175. And then adding those up quickly. It gives me a total of 490. So then the mean is going to be sigma fx, or sigma fa in this case, divide by sigma f, sum of the frequencies. So that is 490 divided by, oh, they didn't give us the total, it's the total of this one. So 18 plus 15 plus 7. What's that? 40. Giving us a mean spend of £12.25. Now in 11b, we're told that using the till receipts, the manager works out the actual mean amount spent for each group, and they've been given in this table here. Without further calculation, decide whether the actual mean of the 40 customers will be different from the estimated mean. Now, and we need to decide whether it's going to be the same or higher or lower. Now let's think about what we did when we worked out the estimated mean. We used the mid values of each of these. So from 0 to 10 we used 5, from 10 to 15 we used 15, and from 20 to 30 we used 25. So you can see that the amount that was the actual spend here was less for that group. It was the same for this one, and it was less for this one. So I would say that overall it's going to be lower, and the reason is the actual amounts were less than our estimated midpoints. So the actual in the times it takes 10 people to complete a task, and we can see that it took one person between 0 and 20 minutes to complete a task. It took 6 people between 20 and 40 minutes, and it took 3 people between 40 and 60 minutes to complete the task. Now there's a series of questions underneath that we need to decide whether or not are true or false, depending on the information we've been given. So the mean could be less than 20 minutes. Now, is that possible given the data that we've got in the table? Now, with group frequency tables, you do lose a little bit of the accuracy because we don't know for sure what value that one person who completed the time in between 0 and 20 minutes took. I mean, it could have taken them 1 minute or it could have taken them 20 minutes. So, depending on where within those ranges these people actually lie, is it possible for these things to have happened? So, could the mean be less than 20 minutes? Now, let's take this one person here who got a time between 0 and 20. The time needs to be strictly greater than 0, but we can use 0 as a boundary on this calculation nonetheless. So I'm going to assume that this one person took a time of 0 or as close to a 0 as it could get, so it's actually slightly bigger than 0. And the same, we'll take the lower bound of the other two. So let's assume these 6 people took just over 20 minutes and these 3 people took just over 40 minutes. Then multiplying those through, 1 times 0 is 0, 6 times 20 is 120, and 3 times 40 is 120. Gives you a total of 240 minutes. And if you divide that by 10, then that's going to give you a mean of 24. So the mean cannot be less than 20 minutes then, because if I take the smallest possible bounds, I only get a calculation of 24, so that's got to be false. The mean could be more than 40 minutes. Okay, let's do the same thing. At this time, let's assume then that it's the upper bound of those categories. So I'm going to have a time of 20, 40, and 60 for those 3 groups. So 1 times 20 is 20. 6 times 40 is 240, and 3 times 60 is 180. Now adding those up, 2180 is 200 and 240 is 440. Divide that by 10 is going to give you a mean of 44. So yes, it could be more than 40 minutes. That is true. The mean could be less than 40 minutes. Yeah, of course it could. We've said that we've shown that the mean has to lie somewhere between 240 and 24 and 44 now, haven't we? So it could easily be less than 40 minutes. Now, can the range be more than 40 minutes? Now, the range is the difference between the highest possible value and the lowest. So let's take the lowest possible value for time in the first category and the highest possible time there. That would give us a range of around about 60. So could the range be more than 40? Easily, yes it could. Could the range be less than 40 minutes? Okay, so let's assume that first person is at the upper bound then rather than the lower bound. So here at 20, and let's assume that all those 3 people are at the lower bound there of 40. Then the range of those would be 40 subtract 20, which would be 20. So could the range be less than 40 minutes? Yes, it could. And could the range be more than 60 minutes? Well, we said the range could be 60, but it can't be more than 60. That is definitely the upper boundary, so that is going to be false. Question 8. The table shows information about the distances walked by 120 students on their way to school in 1 week. And you can see that we've been given a grouped frequency table for those distances. So I've got 0 to 5. There are 20 students who walk between 0 and 5. 48 students walk between 5 and 10 miles. 30 students walk between 10 and 15 miles. And 22 walk between 15 and 20 miles. Now we're asked to work an estimate of the mean for this data. Now the problem is that this data has been grouped, so we don't have the precise values, but we're estimating. So we're going to use mid-x as an estimate for each of these. So you find mid-x by adding your 2 n values together and dividing by 2. So 0 plus 5 is 5, divided by 2 is 2.5. You're basically averaging out the 2 endpoints. 5 plus 10 is 15 divided by 2 is 7.5. 10 plus 15 is 25 divided by 2 is 12.5, and 15 plus 20 is 35 divided by 2, 17.5. Okay, once you've got the mid-x, then we can work out f times x. So grabbing the calculator, 20 times 2.5, that gives me 50. 48 times 7.5 is 360. 30 times 12.5, 375. And 22 times 17.5, give me 385. Oops. Okay, and then just need to add all those up to get a total. So 385 plus 3.75, sorry, 375 plus 360 plus 50. That gives me a total of 1,170. 1170. So then my mean, my estimated mean, is going to be my sigma fx divided by my sigma f. In other words, the sum of fx, which is this value here, 1170, divided by my sigma f, that's the sum of my frequencies, which is this value, 120. Okay, just type that into the calculator again. 1170 divided by 120 is 9.75. Okay, so that's my answer, 9.75. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.